This session is going to be in two parts. The first part is a PowerPoint presentation, and the second part is where we really get into the software to do the data cleaning. So I'm handling the session on data cleaning, the great data cleanup, basically giving an overview and some practical steps of how to clean data with different statistical packages. I will be focusing on Excel for most of the workshop, and I will probably demonstrate, if we have enough time, a more advanced statistical package. I'll be providing a quick background to data cleaning and then list common data errors that we encounter frequently. And then I will talk about how to identify and correct these errors. Like I said, the focus is really on Excel because almost everyone uses Excel. But again, just like we learned from the last presentation, there is a general movement towards more advanced statistical programs. And one of them is what I will be displaying at the end of this discussion. Data cleaning, let me hear from one or two people in this group. You can use the chat function, or you can switch on your microphone. Do we know the difference between data set, and information? Anybody? Does anybody want to help me with the difference between data sets, and information, just for a start, as an icebreaker?
I'll go, Braimoh. I think data set is, the data that you have that has been collected in a school, for example. It could contain EMS numbers. It could contain all the variables that were collected in a school, for example, a child's name. Then it could be and it's coded 1, 2, 3, 4, and 5, and so on and so forth. And information is about maybe the protocol of that data, the information that is handwritten to say, this is the protocol of what it is in the data set. Thank you.
Thank you very much. Okay, and there are also some comments in the chat box. Someone said, I must admit I'm not very clear at all. And another person said, I'm not clear on the differences. Okay, and Kosi, yeah, data is raw, unprocessed information, says Kosi, and information is analyzed data, but data is raw. Okay, that's generally correct. And thank you very much. I will combine what all of you have said and differentiate between the three. All right, let's take it like this. Let's take it like this. When you ask someone what their age is, and they tell you they are 25 years, and you ask another person their age and they tell you they're 23, and so on and so forth, that is called data. Data, therefore, we can define it simply as unprocessed facts. Facts that have been collected but have not been processed. Now, a data set is where you store data. A data set is a rectangular table made up of columns and rows. The rows are the observations, the units of measurement, and the columns are the variables, the data you have collected. So data is unprocessed facts. A data set is a rectangular matrix that contain data. Information, on the other hand, is processed data. Like someone said, data is raw, information is processed. Data is unorganized, information is organized. So if you do not analyze data, you cannot get information. It is not possible to get information without data, but it is possible to have data and not proceed to information. I hope that's clear for everyone. Maybe that's the first learning point this morning. Data, unprocessed facts, data set, the table that holds data, information is processed data. Never analyze dirty data. Garbage in, garbage out. The quality of information that you give out there, the quality of knowledge that follows, the quality of the decision that are based on that information depend on the quality of the data. Quality data, quality information, and quality decision making. So take home point, never analyze dirty data. Clean data before analyzing them. Sometimes it's a little massage you need to do to have clean data. At other times, you need to do real dirty work. You need to do the dirty work, the big data cleanup, which is what we are covering today. Now, I want to show you 5 common data errors. So if somebody asks you tomorrow, what are the 5 kinds of errors we can encounter in data, or 5 common errors people often encounter in data, here they are. And in fact, if you're a database designer or a data analyst, you should know these errors so that, number 1, you can learn to mitigate against them, but number 2, you can also correct them when they occur. Of course, these are by no means exhaustive. Number 1 is duplicate records. Number 2 is extreme values. Number 3 is illegal values. Number 4 is missing data. Number 5 is incoherent data. So I'm going to talk about these 5 common types of data errors in this PowerPoint lecture, and then we go to a practical session where I demonstrate how to detect them and how to correct them. Before I go into these 5 types of common data errors, I just want to say that as a way of thinking when approaching data cleaning, I encourage you to keep the original copy of your data set. A data set is not an essay that you sit and write. A data set is not a report that you sit and write. A data set is a rectangular table that you go into the field, spend a lot of money and time training field workers to collect data, and then you do not want to mess that up. Of course, I cannot overflog that issue. Keep the original data set. And then the next point is when you're cleaning your data. Now, I will be using data and variable interchangeably in this lecture or in this workshop. Why? Because a variable is something that changes values from one unit to another. A variable holds data. So, number 2, keep your original variables so that when you have cleaned the data, we can see where you're coming from. Sometimes the data cleaning step is a very light one, and you clean the original variable. But for the most part, when you're cleaning a variable, ensure to have the original unclean one, and then you have the final clean one so that you can compare. It's not a must. What is a must is to have a backup of the original data. It's not a must to keep the original variables, but I encourage you to do so. Now, let's go into data cleaning with software. Remember, I said I was going to focus on Excel. So let's start with Excel. The first type of data error is duplicates. How do you identify whether a data set has duplicates? Duplicates in data sets are identified or are determined by unique identifiers. So there should be a column, a variable called unique ID, study number, student number, whatever that variable would be, that will be unique for every respondent or observation in your data set. So if you have a variable like that, it's easy to tell when there is a duplicate, because that variable should be unique. Now, I say that if that variable is not present, if it for any reason you do not have a unique identifier, it is possible to combine a set of variables you think can be unique. I mean, you can imagine that if I ask you to list a few variables we can use to identify students in the absence of a unique identifier, I can imagine some of you will begin to list date of birth and the likes. So such variables like date of birth can help you to identify unique records within your data set. But of course, we know very well that there are only 365 or 66 days in a year. So the likelihood of duplicate on a particular date of birth still exists. So it is good if databases have a unique identifier. And of course, if there's no unique identifier, you will then have to use a set of variables, combine them together to form your unique identifier. And of course, like I said, date of birth, it would be great if date of birth was one of those variables. Duplicates are not necessarily determined by response data. Now, you don't say two records are duplicates because the two records provided the same data from A to Z. There is that likelihood to find two people in a school, in a survey, in a data set that have the same age, the same gender, the same race, the same place of birth, and so on and so forth. And you ask them if they smoke, they give you the same data. Whether they drink, they give you the same data. So it's really good to have a unique identifier and not rely on response data for unique identification, even though we do it and it is possible. How do we detect and fix duplicates using Excel? We have the menu approach and the function approach. What I'm going to be covering in this workshop is the menu approach, just because of time. Another kind of data error is what we call extreme values. Now, extreme values are found in numerical variables. For those of you who do not know, or maybe I shouldn't assume, let me just ask, because we have many people here, let me just ask, do we all know the difference between numerical and categorical variable? Quickly put your answer in the chat box. Can you differentiate between numerical variable and categorical variable? Most people are going to say yes. If you don't know, quick, just put a no there. Okay. Now, Google, if I went around the participants in this breakout session and I have a variable called sex or gender, and I come to you, I say, are you male or female or transgender? That is a categorical variable. The answers to such variables can be put into categories. You are either a male or a female. Now you can quickly extend that example to race. You are either black or white or colored in South Africa. But if I went around the same group of participants and I asked for their ages, now one person will say to me, I'm 21, another will say I'm 35, another will say I'm 26. That is numerical. While sex is categorical, age is numerical. And blood pressure would also be numerical. Height, would be numerical. Google, can you quickly give me an example of a numerical variable? Yes, you are correct in your answer that marital status is categorical. You are either married or single. Google, quickly give me an example of a numerical variable. You can type for such straightforward, simple questions. You can type. If I need someone to explain something, they can use their microphone. Because I was explaining to Google, I just want feedback from her. Yes, you are correct, Malinga. Age is numerical. Number of women in class is numerical. Thank you. In one class, there'll be 20 number of learners, you wrote actually. In one class, there'll be 10 learners. In another class, there'll be 15 learners. In another class, there'll be 18 learners, for example. So parity, number of live births a woman has had, that would be numerical as well. So you are all correct. So we proceed knowing this. It's very important for us. It was very important for us to make that distinction because after extreme values, I'm coming to a different kind of error. Number of people employed is numerical. Dietary preference is categorical. Absolutely perfect. So guys, on this slide, let's think numerical. A simple example is age. There are extreme values that sometimes we find in our data set and we say, whoop, this is not possible. This cannot be correct. Extreme values are values that are implausible, that don't make sense. And in statistics, we have another statistical jargon we call outliers. Now we have a very clear statistical definition for outliers, but I won't go into it. But some of you would have heard the term outliers. That value is an outlier. Okay, so let's look at extreme values. Now, what error do you see in this variable called age? Because it's a workshop, I'm not just going to talk to the end. So please get your chat box ready and interact with me so we can go faster. What error do you find here? What error do you see? Thank you. The age of record number 4 is pretty high. Thank you. Now, how would you fix it? Now, before we talk about fixing it, can somebody give me the mean and the standard deviation of this data? Give me the mean and the standard deviation of this data. Put it in the chat box. You have your calculator with you, the mean and the standard deviation of the data. Okay, the mean is 28. Can anyone find the standard deviation? That's going to take time. We can ignore that. Don't worry, because you might need to put that in a statistical software like Excel or something. All right. So the mean is 28. Let's ignore the standard deviation. The standard deviation is very high. I think it was about 60, 70 or so. Was it not this data? I've forgotten the standard deviation myself. Okay, so now I've created a different column, a different variable called H2. You see, I'm practicing what I preach. The old variable is still there. The new variable is now there for comparison. In the new variable, I have removed 61. Can somebody please give me the mean? The mean of these 3 values, you actually don't need a calculator. Yes, thank you, Taki. You actually don't need a calculator to get that. The mean is 17. What does that tell us? That tells us that extreme values can invalidate our statistics, our information, and our decision. When you tell me that the mean age of a group of students is 28, what do I think? I think master's and PhD. When you tell me the mean age of a group of students is 17, what do I think? I think grade 11, 12, or in that range. Now, 16, 17, and 18 are data. The mean is information. So with that information, the mean, because when you've processed the data, you get the mean. The mean helps me to think about the context from where the data came from. The mean 28 makes me to think of the university, but the mean of 17 makes me to think of a secondary school, the high school. This is how extreme values can send you to two different locations. Okay, so that's wrong. The standard deviation should be on this side. 28 and 22 should be on the first one, and 17 and 1 should be on the second one. So we're seeing the standard deviation is actually 22. How do you fix this in Excel? I'm going to show you how to fix this in Excel. I'm going to have 3 approaches to fixing this in Excel. Because of time, I might do one of the 3. So let's quickly go to number 3. Now, we've talked about numerical variables, but we can also have errors in categorical variables. These errors are called illegal values. Many years ago, when I started my career in database development, we used to use EpiInfo, EpiData, and some of those software for creating databases. And CDC was behind EpiInfo. Now, they would say any value or category that shouldn't be in a variable is called illegal category or illegal values. And I've actually, it's not a term that's used by many people. You can call it wrong categories, but I have since then called it illegal values. And actually one time I went to the internet just to check how popular this phrase is, and I saw that some people are actually using it, illegal values. So extreme values for numerical variables, illegal values for categorical variables. Now, let me ask you a question to drive home the points. If somebody says, Braimoh, here are the categories of sex of the participants in your class. One category is male, another is female, the third category is Black, and the fourth category is transgender. Which of these 4 categories is illegal? Please put it in the chat box. Male, female, Black, transgender. Which of them is illegal? Black. Thank you. Because that is not a category for race. Now, illegal values would happen in your data set if there's an error in questionnaire design. If the person who designed the questionnaire has put a wrong category there. But also, sometimes the person hasn't put a wrong category there. The person has made a spelling error. Or it's made it a free-flowing text where people can type their sex instead of selecting from a drop-down menu, as you heard just now when Kelly and Daniel were presenting. Now, instead of having a drop-down menu, the person has programmed that question to be a free text, And as a result, some people have typed female correctly, and others have typed female with double A. I must quickly tell you, if you didn't know, that in a text field, a space is a character. So that even if you have female spelled correctly in 2 different places, if one of them has an extra space, whether a leading space or a trailing space, those 2 categories will appear as different. So here is an example. Please tell me the percentage female in this data set. The percentage female in this data set. And thank you very much for your participation. It is going very well. Exactly. Yeah, you see, somebody says it's 50%, another one says it's 25%. I think you mean 25%. And yes, you see, percentage female, 25%, and woman, 25%. Thank you. And then we fix it in the second variable and we get different percentages. Percentage female here is 25%. Now that we have fixed it, because there's an illegal value there called woman, we now have 50%. How are we going to fix this in Microsoft Excel? I have put together a very clean, I hope so, I hope it's clean, step-by-step document so that even if time doesn't allow me to finish here, I'll send you the file, you will have the file and you can replicate the steps. So we can use the filter, search and replace functions to detect and fix the data. Missing data are almost inevitable. We cannot force people to respond to data, to a survey. However, in a closed system, like in a classroom, a school system, where the data is coming from especially our secondary data, you would expect completeness. What do I mean? The exam performance of students, you would expect completeness. But if you go into a population and conduct a survey, you cannot force people to respond to all your questions. So missing data are inevitable, even in closed systems. So how do we deal with missing data? How we deal with missing data really depends on the extent of missingness and the objectives of the analysis. So one of the things I'm going to be teaching you is how to calculate extent of missingness. So we're going to calculate missingness and we're going to decide to ignore missingness or to treat missingness depending on the extent of missingness. Number 5, incoherent data. We have all seen incoherent data before, where data in one variable do not agree with data in another. You've probably seen that data where a 10-year-old said they have 3 children. In one question, under age, they said they are 10 years. In another question, down the line in the tool, they say they have 3 children or they are in grade 12. Another example is somebody who said they are non-smoker in one question. In the next, just the following question, they now say they smoke 10 cigarettes. How do you deal with that? Well, we're going to use logic. A man cannot be pregnant. Common sense. When we are treating or cleaning incoherent data, we use logic. A man cannot be pregnant. And then we also have to ask ourselves, let me ask you in this class now, if somebody said in question 10, they do not smoke, and in question 10.1, they smoke 10 cigarettes. Mind you, the database designer should not have allowed 10.1 to be completed if he had designed the database well. But many people continue to collect M&E data in simple software like Excel. It's okay. So 10, I'm not a smoker, 10.1, I smoke 10 cigarettes. If you had to make a judgment call, put in the chat box what your judgment call would be. Would you say the first question is correct on smoking, or the second question is correct on number of cigarettes smoked? Or none, cannot be both. That's great. You would have to call and find out. You see, we'll talk about that. Maggie says the first question will be correct. Cannot be both, definitely. So we're left with 3 options. But they're either both wrong, we either make both of them wrong, or 10 is wrong, or 10.1 is wrong. Okay, yeah, so it would depend. It would be a case-by-case analysis kind of thing. But what I would say is consider, do numbers weigh more than categories? Because it's very easy for somebody to select a wrong category. The likelihood of selecting a wrong category is higher than the likelihood of typing 10, especially when it's double digits or 3 digits or 4 digits. The person actually went there and typed 10. So in that instance, you might say numbers outweigh categories, or like Maggie might say the first question is the filter question. That's the one I'm going to use. A third option might be to check other fields. When did you start smoking? How many years have you smoked? You might check other fields and see where there is agreement. And all of the functions we've used in the previous examples can be used to fix incoherent data. Now, let's go to Excel before I hope I have time to come back to more advanced packages. Just give me a second to drop this file for you in the chat box. If you can download it, that will help you as I progress. All right, I've dropped an Excel file for you in the chat box, and I'm now going to be sharing that file. Please download it as quickly as you can. I think I haven't sent it to everyone. I'll just drop it again. Give me a minute. Lovely. It's there. Give me a yes if you can see the file. Type a yes in the chat box. Is that the PowerPoint I have dropped? Oh, okay. It's good to have the PowerPoint. Yep. Now this data cleaning. No, what am I dropping there? Oh, that's my, okay, give me a second. I'm sorry. Yeah, that's Excel. Now, the second PowerPoint I dropped, you can ignore that. That was a skeleton. Now, this is the Excel file. Please give me a yes if you have seen the Excel file. Give me a yes if you have seen the Excel file. That's the Excel file there. All right, I have my first yes. Thank you. I can proceed. Can somebody kindly tell me how many more minutes I have? Thank you, Maggie. 14 minutes, I can do 3 or 4 errors, I believe. Okay, I have put this together specifically for you. I don't use Excel often. I use more advanced statistical packages, and you'll see why I should try to reserve 4 minutes to show you 1 or 2 advanced statistical packages. But I understand that everyone is not a statistician. And Excel is really functional. Excel is really functional. As with any other software, the more you use it, the more it becomes second nature to you. So let's go. Now, this is background information for you. Demographic characteristics. The data set is about grade 9 students in a particular school in Gauteng. I believe you can see my screen now. Noktula? Thank you. Now, each worksheet focuses on a data error, the 5 data error I've talked about. And steps are given for addressing the errors. You do not have to use all the steps. Use what works for you. The correction effected on the errors identified in a worksheet will be seen in the following worksheets. So when I fix duplicate, you will not see that I fixed duplicate here, because if I fix it here, you will not see the duplicates. Okay, but the correction will be seen in the next, you will be seen here. Here, they are no longer duplicates. How did I fix the duplicates? Let's go. Okay, so I'm not going to rush. I'd rather teach 2 things well than rush 5 things, because I believe I have detailed steps for you here. Now, can you tell me, do you see duplicates in this data? Do you see duplicates in the data? And which ID numbers are duplicates? Or where are the duplicates, I should say? How do you know there are duplicates? Now you can use the microphone if you want to. Thank you, everybody. Student number 1 and 4. All right. Pay attention again. Pay attention again. Student number 1 and student number 4. Student number 1 and student number 4 are duplicates in quotes. Are they true? Which of them are truly duplicates? Pay attention again. Thank you. Number 4. So number 1 is not a true duplicate. Now let's remove the duplicates. How do we detect duplicates? Number 1, you detect duplicates by, you can sort like I've sorted this data. You can see 1 and 1 and 4 and 4. That's only possible. That's only possible where the data set is small. But if the data set is big, you will not be able to see all the duplicates. If it's a large data set, you'll not be able to see all the duplicates by sorting. So let's use conditional formatting. Please come to conditional formatting here and go to rules. Please, because of others, try and go with me. I have 10 more minutes, okay? And come to duplicate values. And it says, which kind of formatting do you want? Do you want me to fill the text? I'm saying this because some people are new to Excel. Do you want me to use red font, or do you want to choose yours? Please click on custom format. Once you click on custom format, a dialog box comes out. I want to make it more obvious. That's why I'm not using font. Click on fill rather, and choose any color you like. Red for danger or amber. Let's use that. Orange. Click OK and click OK. What has happened now? Sorry, I don't think I've selected my data. Let's go again. Let's go again. Format. It allows me to repeat the steps. Duplicate values. And you see what it's trying to do. And now that's also wrong. Sorry. If I do that, that's going to be problematic. Just click on student ID only. Format, duplicate values, and you see it's already doing what you want it to do. We didn't select the data earlier. Thank you, Malinga. And then I just prefer this. I just prefer to fill. That's me. You can use font if you like. Great. So that is how you identify duplicates, because if you sort in a database of 10,000, 5,000, you're going to struggle. And then you can insert filters if you like. Okay, let's say come here and do filters. Now let's filter by color and choose that. Then if you have a data set of 5,000 people, you will be seeing your duplicates. Did I leave anybody behind? Clear. Please give me a yes if you have been able to do this. All right, now let's delete the duplicates. Data, and you go to your, click on data here. Let's delete the duplicates. Data, it's very important for you to see what you're deleting. So that step was very important. Data, come here and say remove duplicate under data tools. Under data tools, where you split columns, click here on remove duplicates. And then it says to you, do you want me to use all the variables in the data set to remove duplicates, or unselect and tell me which variable to use as your identifier? If I use only student number, it's going to delete, it's going to take 1 as a duplicate and take 4 as a duplicate. It's going to remove 2 records. I don't want that. So I want to say, please select all, and don't forget to say my data has headers. Of course, it depends on whether your data has headers. If it doesn't, if you don't click it, that's what will happen. So we click it, and it's going to say to us 1 duplicate has been removed and 15 unique observations remain. Done. Please go with me to the next sheet. Duplicates do not exist in this sheet. This is where I will end the session. I believe you have gained something. Now, let's look for extreme values. Now, please help me look at age. Look at age. Do you see extreme values in age? Tell me what the extreme values are and why you think they are extreme values. Yes, thank you. It's only 95. Okay, yeah, some people see, no, 16 is not record. Yeah, record 16, you're right. Okay, some people also saw 5. Now, because when it's a big data set, I'm not expecting you to see everything. So I want to show you the if function. How do you want to identify your extreme values? I have different steps here. Step number 1, sort. I can sort this column and go to the bottom and go to the top. If that works for you, do it. I can calculate minimum and maximum, but that will not quite help because you can have a maximum of 95 and you can have another value that's 80. So let me use a function. Guys, I want to show you the if function in Excel. Please type equal to if. Type equal to if age, that's that value E2 is less than 13. Remember, when I told you about the data set, I said the age range is 14 to 16, and you will have to define the range for your data set depending on your analysis and study. Anybody less than 13 is suspicious. Or because we said 14 to 16, we have to say less than 14. Okay, now, if it's less than 14, what should Excel return? Type there, too low. Okay, let me show you something. Type 1. If it's not less than 14, what should Excel return? Type 0. Close it. Enter. Now, click on this expression again and see what it says. If this is your argument, if it's less than a figure, this is what should happen. Otherwise, this is what should happen. And then you feel, okay, it doesn't matter. Let's just remove that. Oh, that's wrong. That's 0. Okay, that's correct. Please give me a yes if you have been able to do this. I'm so conscious of time. Of course, I should be. Give me a yes if you have been able to do this. Or should I slowly go through it again? Thank you, Taklani. Oh, Rosaline excluded. Okay, somebody else? Yes, thank you, Maggie. I'm waiting for the others. May you explain what 1 and 0 is? Thank you. I'm going to do this again. Okay, guys, thank you, Maggie. This variable, I have called it, oh my goodness, 57 seconds. Guys, this column, I have called it extremely low. So I'm looking for outliers that are too low, and this one, I've called it extremely high. Outliers that are too high. So here, I say, if this value, E2, is less than a particular cutoff, then it's 1. 1 means yes. If it is not less than that cutoff, cut 14, it is 0. 0 means no. Are you with me? So That is why this is 0, and this, where is 5? 5 is 1, because 5 is less than 14, and missing is less than 14, and nothing else is less than 14.